What's up, guys? Today we're going to be doing problem number 4 of homework number 2 for Natures of Materials. Right now I've written down our givens and also the questions we want to answer. So for part A, we've got what is the volume of the unit cell in cubic meters, and the equation we're going to be using for that is this equation right here, and we're initially given density. But what we want to do is get it so that we're given, or so that it's equal to the volume of a unit cell. And if you're asking like what do each one of these mean, we've got N is equal to the number of ions per unit cell. We've got A equal to the atomic weight, and in this case it's titanium, and then also VC is volume of unit cell in centimeters cubed, and Avogadro's number is N of A. So to get it into the right spots, we're going to do VC equals N times A, and of Ti, because it's titanium, times P times our Avogadro's number. And so the first thing we're looking for is the number of ions per unit cell. And we're given that in HCP structure. So we know HCP structure is equal to 6, and we know this because we have 3 internal ions, 2 ions on the faces, and they're both just half on, half off, and also 12 ions on the edges, and they're 1/6 on, and that's a total of 6. So now we have VC equals 6 atoms per unit cell. So our first number, and then we also know that the atomic weight of titanium is 47.9 grams per mole. So we can write that next. Boom. And then we're also given our p-value right here, which is density. Make that a better looking 5. That's 4.51. And then lastly, our Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole. And then from here, we can cross out our units, grams, moles, and we should end up with VC is equal to 1,058.10 to the negative 22 centimeters per unit cell. As you can see, centimeters cubed from there, centimeters cubed, unit cell. But we want it in cubic meters, so we're gonna make that into 1.058 times 10 to the negative 28th meters cubed divided by our unit cell. And that is part A. So part B, we want to compute the values of C and A. So the C to A ratio is actually like the axial ratio, and we're also given the equation for this one, which is VC is equal to 3 boom. And what we want to try and find here is A, because we're given C is equal to 1.58A. So we can plug in the C value into here, and once we substitute it, we get VC is equal to 3.58 A cubed, because we're adding the 2 A's, And since we have our VC value now, we can also equal that to 1058.10 to the negative 22 centimeters cubed. We want to keep this centimeters one just for conversion. And so now we have that, and we want to switch our equations so that we have A on the one side and everything else on the other, and it's easy to multiply. So once we do that, we have A is equal to 2 times our VC value divided by and all of this is in the 1/3. And once we get that value, it is equal to 2.96 times 10 to the negative 8th centimeters. And just for ease, we're going to change it into 0.96 Newton meters just for our next step for getting C. And we're going to flip over real fast, not catch on fire. So C is equal to 1.58A, and our A value was 0.296. And once we plug that in, always remember your units just in case. We get C is equal to 0.468 Newton meters. Boom. So that's it. We have our VC, our A value, as well as our C value. Have a good one.